Selenium has 6 valence electrons. Think of an atom like a house with floors, where the outermost floor holds the electrons that decide how the atom behaves. And for selenium, that outer floor is the 4th shell, which contains 2 electrons in the 4s orbital and 4 electrons in the 4p orbital, making 6 valence electrons in total. The electron configuration shows the inner floors filled first, like a comfy basement, and the outer floor left with those 6 electrons that form bonds or take part in chemical reactions. You can tell valence electrons by looking at the highest principal energy level in the electron configuration, which for selenium is 4, and counting the electrons in the 4s and 4p orbitals. Those 6 are the ones most involved when selenium gains, loses, or shares electrons in compounds. A common mistake is counting the electrons in filled d orbitals as valence electrons, which confuses students because d orbitals are from the previous shell and usually do not act as valence electrons for main group elements. Focus on the highest principal quantum number instead. Another misconception is forgetting to include both the s and p electrons in the outer shell, so students might only count the p electrons and say 4 instead of 6. Always add the 2 s electrons that share that same outer energy level. One quick tip is to write out the electron configuration and highlight the highest number shell, then add the electrons in the s and p orbitals there. For more videos and resources on valence electrons and electron configurations, check out www.gumballdegree.com.